Hey y'all, it's Josh, the BMW guy again, doing a S55. Gonna go turbo action. Have a customer with a M4. He was cruising down the highway and it started rattling and banging. And his other motor, the number 6 rod let go, and it cracked the bell housing in this area. I say the bell housing, cracked the block, and whenever it split the block, it split the transmission. And so fairly catastrophic failure. So we're going to be starting with a good used motor. But we're going to be going ahead and doing some upgrades to it to make it, I guess, a little more dependable at some higher power levels. We're going to be tearing this one all the way down. Going to be upgrading the connecting rods, upgrading the pistons. Going to be upgrading the turbochargers. Not doing any camshaft upgrades. The camshaft on this one, or the camshafts, are more than adequate for our power goals. We're going to be relying more on the turbochargers to make more boost to generate more power. Going to stick with the stock crankshaft. It is a 3-liter engine and it will remain 3 liters. But yeah, we're just going to do turbo upgrades, rod upgrade, piston upgrade to make it handle the increased boost pressure. And hopefully we'll be able to put between 700 and 800 horse at the wheels on E85. But everything internally inside the motor should be capable of doing well over that. So later on, if he gets the want to make, 800, 900, 1,000 horsepower at the wheels, he'll be safe to do it as long as he can get the amount of fuel in it to make it do it. Going to be upgrading the fuel pumps to provide additional fuel to the engine because that's what makes it survive. So yeah, this is going to be a neat little build. Can't wait to see how it comes out, and I will keep you all updated. All right, everybody. So back to the M4 motor. We got a used motor and it arrived like this. And we got another used motor from the same company and it arrived with the same issues, but even worse. So we decided to take matters into our own hands and we went ahead and got the block sleeved with iron sleeves. It does 2 things. It allows you to get back to a fresh standard bore, but also the iron sleeves actually do provide some strength. Instead of just being aluminum, you have an iron sleeve inside to give it some extra rigidity, less distortion, all that kind of stuff. So, but now that we have these beautiful iron sleeves installed, thank you VAC for the wonderful work you have done for us. We're going to go ahead and start putting this motor together. Finally, we got all of our numbers for the bearings and everything. We just went ahead and got VAC to send us the coated bearings we were wanting. So I'm going to start putting this together, checking out some of our specifications, make sure all of our clearances are looking good, check our in play, and go from there. All right, y'all, so got a little diagram of all the different bearing halves that are to be used. BMW likes to run different bearing shells depending on where it's at in the engine. And let me find the stencil for you. So this is the stencil that they use. All the E's coincide with different bearing colors, which coincides with different bearing sizes. Now, all the bearings look like normal bearings, which you would think, just your typical like half shells kind of deal. They all have different colors. You can see right there, this one's brown. And so the one bearing that's going to be different is the thrust bearing. You can see it right here. All the other ones don't have ledges on it. This one actually has ledges on both sides. And so what that does, it controls the front to rear movement of the crankshaft. You want to have a little bit, you don't want to have too much. So now the crankshaft also has stencils on it. BMW goes off of these, all the 4s and the R's. It just means it's using the same shells kind of deal. But anyway, so, but that is from the factory. That's from BMW. That's how they let you know what bearings to use. All right, guys, so we got the crankshaft in, and everything is clean and dry. Now, after I'm done taking my measurements, I'm going to make sure to spray some light oil on everything to keep it from rusting. I am going to cheat a little bit. I'm going to use good old plastic gauge. A lot of people talk trash about it. It is a very simple and accurate way to measure clearances, and it's a physical measurement, not a calculation. I like it because if it's something's out of whack, you can kind of see it. But the trick is everything has to be very clean. If you have any oil, any residue, you will not get a proper reading from it. I'll probably go back with my snap gauge and bore dial and all that stuff and get some measurements, but I'm just curious to see how it plays out using some plastic gauge. So anyway. All right, so as you can see, we're doing the lowers right now. This is the bed plate, and it is blue. Now, something I found interesting on this engine, the bed plate doesn't have a thrust washer. If you go on the top side of the engine, you can see this is the one I had showed earlier with the two sides to control front to rear movement. And normally they have the same thing on the other half, but on this one they just want you to run a regular bearing. I mean, it kind of makes sense. You're controlling movement, and you don't need to have both halves controlling the movement. But this is the first engine that I've personally put together that only has the one. I had to go and double check and make sure that I wasn't like losing my mind, but that's yet to be determined. But it does not need it on both halves. Just wanted to show you all the plastic gauge. I just laid it down on each of the journals, and that's all you do. Nice, clean, dry, lay it down. Luckily I don't have any wind, because the wind will blow it away and you'll never see it again. And I'm going to take the bed plate, set it on there, torque it down, then you remove it, and the amount of clearance will squish that little piece of plastic to a certain thickness, and then you measure that how much it's squished out, and that's how you know your clearance. All right, so I had put the bed plate on and torqued everything down, and then as you can see, all my plastic gauge smushed out and did what it's supposed to do. And everything is coming out to about 1.5 thousandths of an inch, which is within BMW's specifications. And let's see if I can get a good video of this. So you put your plastic gauge, and you see it smushed it out to let you know you're at 0.0015 of an inch clearance. Not 2, not 1, 1.5. Nailed it. Good job, VAC. Now, plastic gauge does leave behind a residue. You got to clean that off. I mean, I guess you don't have to, but I always do. And I've tried a bunch of different products. If you've seen my other videos, you probably already know this, but the thing that I found that works the best is WD-40. Apparently the plastic gauge dissolves in oil, and WD-40 helps to dissolve it real good. You just spray it down a little bit, come back with a cloth that doesn't have lint on it, and you just wipe it off, and it comes off clean. So since my crank spec'd out where I wanted it for clearance, I'm going to go ahead and put some engine assembly lube between the bearings and the crank. So I'm going to pull the crank back out, put engine assembly lube, put the crank back in, lube up all the bearings in the bed plate, put it back together, torque it back down again, and then I'm going to check my my end play, basically how much the crank can move back and forth. If I have too much or not enough, your thrust bearing, these little tabs right here, is what you're going to have to manipulate to control that. So hopefully that'll be nice and within spec, because our crank has not been machined. Our bearing is a factory style bearing, so but only one way to find out. You got to check it, make sure. The engine assembly lube I use is by VP Racing. I've been very satisfied with this. Just take it and put a strip of lube on it. I usually take my clean finger and spread it around. And I've already done this side and I laid the crank in. All right, y'all, so the torque spec on these bolts right here are 20 Newton meters. So you torque them all to 20 Newton meters in a specific pattern, start in the middle and work your way out. And the next step after that is 70 degrees. Now, the reason why they use degrees is when you start torquing something, the amount of torque needed to screw something down can be manipulated. So let's say you start torquing it down and the threads are messed up a little bit. So it will take some torque to twist in the threads rather than the torque being applied to pull something down. So what they do to alleviate that possibility is the first setting is a very low torque setting, so it doesn't take much to kind of set everything in its preloaded position. And then you come back and you do a certain amount of degrees because BMW knows that this bolt, when you rotate it a certain amount of degrees, when it's under tension, will stretch just enough to make it at its maximum holding strength before it starts to degrade. So BMW said it was 20 Newton meters, so I did 20 Newton meters on all of them. And then after that, you do 70 degrees. Now, the cool thing about this torque wrench is after I do the 70 degrees, it'll show me how much torque was applied. And so if I do 70 degrees and I see one that the torque is just like way off, I know, okay, something's not right, and I can go back and address it. But I just wanted to show you. So we need to do 70 degrees. There's 71, and it's 62.5 Newton meters. So, and now I'm gonna do all of them like that. The only bad thing about it is that once you angle it, you have to remember which ones you torque to the specific angle. Because it's not like a torque value where you can go back and be like, oh, well, this one, I have to torque all of them to 60, so you can go back and recheck them. Once you set that angle, that's it. So I need to focus, so I'm gonna turn this off so I can keep track of which ones I'm doing. All right, so checking the end plate, basically how much the crank moves this way in relation to the block itself. It's an all aluminum block, and I do not have an aluminum magnet. I know the government only has those. Just kidding. Anyway, having a shop that does its fair share of fabrication, we always have scrap metal laying around, so I went ahead and just bolted a piece of metal to the block to give me a firm base for my magnetic base. And I'm gonna take the crank and just take a screwdriver and push it frontwards and backwards. So that would be the crank push backwards, crank push forward. And so what we're doing is we're pushing it against those little tabs that I had showed earlier. And it shows how much our crankshaft moves front to rear. So right now it's about 0. And if I push it the other direction, we're about 5.5 thousandths. Come back to 0. Yeah, about 5.5. And I'm gonna go look up the spec, but I think the minimum was 4, maximum was 6 or something like that. But I think we're really good in that 5.5 range. All right, y'all, so our connecting rods we sourced from Manley. Manley makes some amazing products. They guaranteed these rods up to 1,200 horse. They have a similar connecting rod. They guarantee up to 800 horse. The only difference, he said, is just the rod bolts. These are just an upgraded rod bolt, and they said it'll do 1,200 horse plus. The pistons we got from a company called JE. JE makes amazing pistons. Every time I've used them, I've been very satisfied, and yeah, these should be no different. JE said whatever you throw at them, they'll handle. So I also told JE what I was planning on doing. They gave me all my rings to go with the pistons, gave me the wrist pins. Very pleased with them. They do great work. So this is our top ring. This is our second ring, and these are the oil control rings. I'm going to have to do some file fitting to make them fit. Basically what happens is this little gap right here at the end of the ring, when you put it in the bore, it gets closer. So it gets tightened up like that. And so whenever, if it's too small, whenever you get them hot, they'll butt up against each other and pop the tops of the pistons off. So we don't want to have that. So, but anyway, I'm going to start doing that. All right, y'all. I know it's going to be hard to see, but this is my feeler gauge, and it does not go between that gap. Now, this one, it's a really hard ring. I guess because we're dealing with so much boost. but as you can see, I can fit it right in the gap. It's about 17 thousandths clearance, and that's what I'm looking for on this top ring. So we're going to go street moderate turbo nitrous bore times 0.0050. So our bore is 3.3 inches. Multiply that by 0.50, comes out to about 16.5. So I erred on the side of caution, went with 17. And our second ring is 0.005 times 3.3, and it came out to like 18.1. So here's the 18, and I took our second ring and pushed it down in the bore, and the 18 gauge fits right through it. So I got lucky. Don't have to grind that one at all. So I'm going to go through all of them and do the same thing, same process, and after that we start putting our rings on our pistons. Oh, and you want to make sure that the ring is square in the bore when you take the measurement, because if it's not, you will not get an accurate reading. So what I do is I place the ring down in the bore, then I take one of the pistons with the rod, and I use it to true up the ring. So take it, and I usually push it down to the bottom of the skirt, you know, about right there. And so that way you know that your piston's down far enough in the bore where everything's lined up square, and then when you pull it out, your ring should be nice and square, and that's when you can take your measurement. All right, y'all, so assembled one of the rods, put the rings on it and everything, got it down in there, and went ahead and decided to plastic gauge my bearings. And I just torqued it to the nominal value that they say, 50 foot-pounds. My final torquing procedure is actually going to be stretching the rods. So you can just torque them to 50 foot-pounds if you don't have a stretch gauge or anything like that, and that's fine. That's one of the ways they recommend torquing it. But you can run into an issue where if you have some trash in the threads or whatever, you can torque it into the trash and not get the full clamping load. So what I like to do for my final assembly is actually use a stretch gauge and stretch the bolt to the recommended stretch. Now, I have over here in my little engine building toolbox is my stretch gauge, and it's from Jigs. Anyway, it's just a dial indicator, and it has a little point and a nub, and the way that you calculate the amount of stretch that you're applying to a rod bolt, you take it and give it the at rest measurement, and I'll just kind of put it on here, make sure that it's sitting perfectly in they put a dimple at the bottom of the bolt, it'll be hard to see, and a dimple at the top, and then you can zero your gauge, and so then you take it and you put it in the connecting rod. And then with it in the connecting rod, they leave you a gap at the top and a gap at the bottom to be able to reinstall your gauge, and then you can look at the difference. And that's how you know how much it's stretched. So that's going to be my final torquing procedure. But coming back to the plastic gauge here, you can see it's a little murky on the bottom right there, but you can clearly see the crush value right here, and the crush is sitting right at 2/1000 of an inch, and I'm very satisfied with that. Like that's good. If you want to see it in a metric value, this is millimeters. I'm just more, even though I'm a BMW guy through and through, I'm just more, I've built a lot of domestic engines because that's, typically I see more people want to build hot rods, small block, big block Chevy, Ford, all that kind of stuff. But anyway, so yeah, this is my rod bearing for number 1 looks fantastic. I'm going to go ahead and put some, clean off the plastic gauge, put some assembly lube, torque it, and then stretch the bolts to, I believe it's like, yeah, 58 thousandths of an inch. So that's 0.0058 of an inch. And so, yeah, once I get that amount of stretch, and the torque value to achieve that may be a little more, maybe a little less than that 50 foot-pounds. It just depends on how cleanly it goes into threads, and also using the ARP assembly lube that came with it. And so, yeah, I'm gonna go ahead and do all the rest of them. And man, at that point, the short block would be assembled, and I'll start doing other things to have this motor complete. All right, y'all, another point of interest. These are oil squirters. So, I gotta get my finger up to it. So this little nozzle right here, it actually takes oil that's being delivered by the oil pump and sends it and squirts on the backside of the pistons. Now, let's see if I can get to focus. You can see it right there. You want it to kind of shoot the middle of the piston as best as possible. It does lubricate the wrist pin, but the biggest advantage it has is that it cools off the piston itself. So by keeping the piston cool, it'll keep you further away from detonation, which means keeps you further away from trouble as far as having a bad tune, or, you know, knocking holes in the pistons or melting holes in the pistons. But it also allows you to run more boost because your pistons are just cooler, so you don't have to worry as much about detonation. So anyway, BMW has been doing this for years. Motor I built was a 1995, no, 93, 94, 325i, an M50 B25 engine. And even back in the early 90s, they had the piston squirters shooting the backs of the pistons. So that's something I always found fascinating with BMW. Anyway, when you put them in, you have to make sure you aim them in a good direction. You want to make sure that you're not going to hit the connecting rod, which I don't know if you can see it, we have adequate clearance there. And you want to make sure that you're not going to hit the piston. I don't know if you can tell, but it's actually up in the piston itself. So if I was more to the left, I'd be hitting that support brace on the piston. If I was more to the right, I'd be hitting the connecting rod. My cousin Jonathan actually built a Hemi that had these, and he did a big long stroker setup, and inadvertently knocked all of those jets off, and they were just bouncing around the engine. So you got to be careful. You got to make sure you point them where you want them, and then make sure you torque that bolt. Let's see, that banjo bolt to spec, so nothing comes loose on you. So anyway, I just always found BMW very fascinating at how they like to cool their pistons off, and it does a really good job. I've made amazing power with that little M54 B25 engine. I put like 530 horse at the wheels. If you want to check it out, go look up Colin Does Drifting. And he actually took that car all the way right up to a pro level. So just, yeah, and from what I understand, the little motor still runs to this day. Got piston number 1 done. And it is so smooth. All right, y'all, so we're installing some upgraded fuel pumps. They're gonna move about 50% more fuel than the factory setup. So still uses the factory It's the fuel pump cam that goes in here, and the fuel pump's bolted to the top of this, but they have a couple adapters that go on, and then the fuel pumps themselves will bolt onto those adapters. But pretty sweet little setup. 50% more fuel, so possibly 50% more power, but the factory pumps they move a lot of fuel already, so this is just kind of a little bit extra on top of that. So all right, so we have our deck surface nice and clean and prepped. Got all our surface ready, our liners are in, and we're about to put the head gasket down and put the studs on. Got our cylinder head over there ready, and move along. All right, y'all, so the factory BMW head gasket is actually a pretty good gasket. It'll hold whatever cylinder pressure you throw at it. It is a multi-layered steel gasket, meaning that it's just multiple layers of stainless that they put together. I don't know if I'll be able to show you. And they have little rivets that hold it all together. You can hear it. And this black stuff is like some sealer that helps seal everything. Keeps all your coolant in the coolant areas, oil in oil areas. We did deck the head a little bit, but not enough to make a difference. So I'm going back with a standard thickness head gasket, and this should get it done. Now we are using ARP head studs. Factory bolts work well, but the head studs do provide a lot more clamping force and a lot more accurate clamping force. One of the things that makes the S55 engine really strong is that it doesn't just have the threads up by the top of the bores. A lot of times what will happen if the threads are right here up at the top of the bore, as you torque it down, it'll pull the bores out of round. So what BMW has done is they really went down deep with the threads, and it grabs it all the way down at the base of the block. So it really gets down into the strong part of the block, gives you a lot better clamping force, a lot more precise load, and doesn't distort your bores like having threads right at the top right here. So that's something that's kind of cool that BMW does on this engine. All right, so we're using ARP head studs, and it comes with the ARP head bolts. These are actually going to be a 9/16 12-point socket, and use plenty of ARP fastener assembly. You want to make sure that you get it on the face of the nut and also on a lot of the threads. I've already put some on the studs down the hole down there. All right, so I got all the nuts just run down by hand. And so ARP specifically says to torque them down in 3 equal steps of 95 foot-pounds. So I'm going to proceed with that. All right, y'all. I kind of had the cylinder head reassembled. I needed the special tool I'll show you, it clamps the two. All right, so this is a clamshell setup right here. So you got a top half and a bottom half, and the cam rides in the middle of it. So with your rocker arms underneath, this is the exhaust side. So there's special tools that clamp on to each one of these flat spots right here and aligns the upper and lower halves of the shell together. So I'm just waiting for those to come in so I can clamp the whole thing before I torque this side down. But on the intake side, I can start torquing it down. So I just torqued down the eccentric shaft caps, 8.6 Newton meters. And I'm getting ready to start torquing down the caps for the camshaft itself. Now, it's a pretty ingenious setup that they have. It basically changes the rocker ratio by moving this eccentric shaft. The way they do that is they use this electric motor. I just have my Allen in here. It does it, via electricity, but for just explanation purposes and installation purposes, I can just rotate it by rotating this, and it turns that little worm gear, which turns this shaft, which turns the shaft right here, which effectively, okay, so the cam right here pushes on this little roller, and then this little roller pushes on the roller pushes on this shoe, I call it, and then that is what pushes down on the valve. So as this turns and the eccentric shaft oval pushes this over, it changes the amount of motion it has on this rocker arm and changes the lift on the fly. And so as it turns, you can kind of see it moving. It doesn't do it a whole lot when you're not running the engine. So anyway, so as it turns, it adjusts that little shoe and pushes the valve open more or less depending on how much throttle is needed. So anyway, I just torqued all these down. Then I'm going to come over here and torque all of these down. Yeah, continue this project. All right, y'all. So this is the BMW timing chain guides. It's a pretty simple setup, works really well. So you have your main timing chain. It goes down there, wraps around the sprocket. I don't know if you can see it. Let's see. There we go. See the sprocket down there? And then comes up to the top. And then it goes, this would be tough to do with one hand. So this is the guide. So the chain goes up through the middle of that. Let me see if I can. All right. And then the guide slides down in there, and it has some pins that hold it in place, which I'm going to show you in a little bit. And then this is another part of the guide. It just clips into place. I'll snap it in and come back to it right there. So I just want to show you that for a second. Let me pause the video and kind of assemble it some. All right, so it goes in like that. So that little piece snaps in right there. It goes all the way down to the crank sprocket down there. I'm not sure if you can see it. Way down there. Anyway, so goes down there, comes up. This is your chain tensioner. The tensioner actually goes in this hole right here and comes out right there. Uses oil pressure to push against that to keep the proper tension on the chain. Keeps all the slack out of it. I'm going to assemble the cam timing units. They go here on the inlet camshaft and here on the exhaust camshaft. And then it's got two oil control solenoids. They go right here. This is going to be your intake, which controls this side. This is the exhaust, which controls this side. And it actually sends oil through the cylinder head. You can see there's the hole right there where it goes. And sends oil through passages that come up to the cams. And they have some bearing ledges, they call it right here. And the oil comes out through these holes. And depending on which holes it's sent it through, will either advance or retard the cam timing in relation to the crankshaft. So really neat stuff. BMW's been doing it for a very long time, since the early 90s, I think they started doing. Yeah, I know for sure, about 92, 93, they started doing it just on the intake side. That's how they figured out that if you take the inlet cam timing and manipulate it back and forth, advancing and retarding, if you advance it, you build low end torque. If you retard it, you make more top end power. And so they do that to get more power. Then later on, they figured out if you manipulate the exhaust cam timing, you can get better emissions. When you first fire up your BMW, if you hear it like really loud, like rah, you're like, what is all that racket? Well, what they're doing is they're taking the exhaust cam timing and advancing it to where the exhaust valve opens really early in the chain of events, and more hot gases come out of the exhaust ports and dump into the catalytic converter to get the catalytic converter hotter faster to meet emission standards. And then after a couple of seconds, use like, I don't know, 30 seconds or so, or if you give it a little bit of gas, it quiets back down. Well, it's because they take that cam timing and put it back where it goes to run for optimum power. So, but anyway, just really cool stuff. So just wanted y'all to see some of the inner workings of all BMW engines nowadays. All right, so got all the cam timing stuff in place. Got the intake cam torqued down. This is just part of the special tool for timing. I just set it on there just to make sure that I had the cams in the proper orientation. I know the engine's at top dead center. The cam has two flats on it. I don't know if you can see them. Two flat sides, there you go, it's a good angle. And the barcode, or little square, it's a barcode. Anyway, so as long as you have that barcode up and the flats are pretty square, you know that you're pretty close to being in time. And I just did it so that way my valves don't run into each other. Same thing on the exhaust side. Now, okay, so this is the cam box on the exhaust side. The cam lives in this box. You can see through here, you got your rocker arms, you got your valve spring, all of that underneath it. There's no variable valve lift, so there's none of this intricate arrangement right here. And so in order to make sure the top and the bottom of the cam box are aligned, they have these special tools that you clamp all the way down, torque it down to 2 Newton meters, and then you proceed in torquing the box down in place. And as you can see, it's 2 halves. There's a parting line right there. And these just keep it all in line for you. So first thing you do is you put them all together, torque them down, everything down to 2 Newton meters, then you do 8 Newton meters, and then after 8 Newton meters, you do 60 degrees of torque angle. So that's what I'm doing right now. All right, y'all, so we got the engine out, and it brought more questions than answers. So if you look at the intakes, we have some that are full of coolant or some type of liquid that's been in there for a while. And then our connecting rod that is broken, the rod is still on the crankshaft, and you can see it still turns freely. So that tells me we didn't have a rod bearing failure. So number 6 is broken, and we measured the pistons in the hole, and number 3 is deeper in the hole than number 4, and they're companion cylinders, so they should be the same. So that tells me that the number 3 connecting rod is bent. So there's a mystery to it. We just got to make sure that this mystery doesn't go on to the new engine, because I think this engine had some type of failure where it sucked in liquid and we hydraulic locked things, and that is what truly killed number 6 rod. All right, so got the M4 driving. Had the engine running for a while, but we did a full, we got a transmission because the other transmission, the bell housing, got split when the block split. So got a used transmission, and knowing that these transmissions, they say they can only handle like 750, 800 horse, we went ahead and ordered some bits and pieces to upgrade. I think I'd already taken a video of that. I'll probably put it in there. Anyway, did a rebuild on the transmission and put the good used transmission with all the upgraded parts in it, and it wasn't happy. It was software issues that my diagnostic computers could not get around. the owner had gotten with his guy who did the transmission tune to try to get it squared up, and his guy couldn't quite put his finger on it. So I had a good friend of mine, Guillermo G Coating, if you ever need some BMW coating and stuff done. He is the man, Slidell, Louisiana. Look him up. He hooked us up. He came over and read out the information out of the old transmission, and then took that information and patched it into the new used transmission. And so yeah, got transmission working for us. Before, it just stayed neutral, like just wouldn't, it was just no fault codes, no nothing, just wasn't happy. So anyway, about to go on the first test drive. I want to put about 500 miles on it before bringing it to the guy to get it dyno tuned. He did put a safe tune in it, so that way we can drive it around and not have to worry about messing up the motor. And so yeah, first test drive, here we go. It's ridiculous. All right, so the owner of the car's had the car back for a while now. We had a little issue that was, I guess, kind of done by me. The front main seal, it was leaking, and it was because I had recessed the front seal a little too far. My hands are dirty. Yeah, work. The front seal was recessed a little too far into the block, and it was leaking. So easy fix, just pull the front seal out, get a new front seal, install it to the proper depth. He's had a few injectors fail. He's running straight E85, so I got a feeling that the E85 is probably a little hard on the fuel injectors. But other than that, I've had no issues. All right, so we stopped at 640 horse at the wheel. 640 horse, 650 foot-pounds. And that was on a fairly conservative dyno. He took it home, and he's like, oh my God, this is good enough. We don't need any more. I'm happy. I need to learn how to drive all over again. So now, excuse the car, it is dirty. He does drive it. It is, he uses it. Oh, sneak peek, new shop, coming along nicely. Very much in the process of. Floor is dirty, as you can see right there. It's clean, but love my M colors. Put it down myself. Really happy with the results. PPG paint, thank you. They gave me a recommendation on what flooring to use, and put it down myself. Anyway, getting back to this. So he got some wheels and tires and put 295s on the back of it, and it still just annihilates tires. I mean, just completely incinerates them. Traction issues now up to 90 miles an hour. Yeah, I like it. It's all right. I'm a driver. I love driving. I love racing. When I say racing, I've been doing a lot of racing with WRL, World Racing League. So I have some experience behind the wheel, raced on a bunch of different racetracks. Anyway, it's a handful for me. Like, you really got to be ready for it, because even in third gear, when the turbos spool up, that back end is walking. I mean, if If it's got decent traction, you can feel the back end squirming around the whole way. Now this is with traction control off. With traction control on, it just flashes at you and pulls power the whole time. But anyway, with traction control off, if you have just average traction, yeah, the back end's trying to come around. It doesn't really start putting the power down until about 90 miles an hour. It's really ridiculous. That for a little 3-liter inline six, oh my God, it is a monster. I wish you would put some drag radials on it and really take it to the drag strip and let it rip and see what it does. But I don't think the owner's going to do that. He just wanted something to have some extra horsepower, bragging rights, basically. And he definitely got it. Like it's a beast. The first time he brought it back for us to check some stuff over, when I picked it up in the air, they had some scrape marks that kind of went like from the driver's front of the vehicle to the passenger rear, so you could tell the car went sideways, and had some scrape marks. So I texted him, I said, the principal would like you in his office. And he says, yeah, it kind of got away from me a little bit. But anyway, he's loving it. It's been super dependable. Like I said, only issues has been injectors, and I don't really blame the injectors for that. I think it's more the E85 that is running through them. So yeah, super happy with it. I'm gonna go on a little test drive and show y'all kind of what it does. It's ridiculous. I really wish it was the all-wheel drive, because then it could really put the power down. But he's so traction limited. But anyway, so yeah, just wanted to let you guys know my little company, LeBlanc Motorworks, is moving on up, getting a new facility going. The M4 is still kicking. The owner's had it a while and has been driving around, and it's been great for him. A few minor issues, nothing crazy. For the amount of power it's producing per liter, really impressive that it's dead dependable. The JE Pistons, the Manley rods, seems to be a really good combination. Making 650, 640 at the wheels all day. And yeah, so I'll go for a drive and let y'all see. If you've enjoyed this video, please like and subscribe.